ठीक है सर।
यस सर।
इसको एक बार शेयर करके देख लेते हैं।
नीचे शेयर का एक बटन दिख रहा है, एरो लगा होगा।
नीचे।
जहाँ स्पीकर है ना, स्पीकर और वीडियो का सिंबल है। सेंटर में शेयर का एक साइन होगा, एरो। पहले आपकी प्रेजेंटेशन वहां पर ऑन कर लीजिएगा डेस्कटॉप पर।
ओ अच्छा, ठीक है।
ओपन कर लीजिएगा, ओपन।
पहले ओपन कर लेता हूँ ना। ठीक है। स्लाइड शो करूँ?
हाँ।
ठीक है, कर लिया।
अब उसे मिनिमाइज कर दें।
कर दिए सर।
अब जूम में आ जाएं, जहाँ आप मीटिंग कर रहे हैं।
आ गए।
यहाँ पे नीचे की तरफ देखें, सेंटर में शेयर का एक साइन है, एरो बना हुआ है।
स्टॉप वीडियो उसके बाद? नहीं।
ऑडियो,
पार्टिस
वीडियो, उसके बाद पार्टिसिपेंट्स, चैट,
हाँ।
रिएक्ट, शेयर।
हाँ, शेयर स्क्रीन, ओके।
शेयर पे प्रेस करें।
किया सर।
वहां पे कई सारे जो आपकी
हाँ
फाइल
हाँ हाँ
शो
हाँ,
हो रही
ठीक है
होंगी।
ठीक है। मैं
आप
अपने
जो प्रेजेंटेशन है उस पे क्लिक कर दें।
कर दिया, शेयर करूँ?
हाँ जी।
हो गया ना?
जी।
बढ़िया।
परफेक्टली आपकी जो प्रेजेंटेशन है विजिबल है।
हम्म।
बस आपके जो सिस्टम में कंप्यूटर है या लैपटॉप है, अप डाउन कीज हैं।
हम्म।
इससे अप
उसको
और डाउन कर सकते हैं आप।
अच्छा, पहले तो इसको स्लाइड शो में करना पड़ेगा ना? हाँ, ठीक है। वाह।
यहाँ से अप डाउन कर सकते हैं इजीली आप।
यस सर, यस सर, एकदम शगास शगास, थैंक यू थैंक यू।
अब आपके डेस्कटॉप पर जो भी फाइलें हैं वो शो नहीं करेंगी, केवल आपकी प्रेजेंटेशन ही शो करेगी।
वाह, ठीक है ठीक है। अच्छा हो गया सर, थैंक यू वेरी मच।
ओके सर। हम थोड़ा वेट करते हैं, दस
हाँ
पाँच
हाँ,
तक, और हमारे कुछ और साथी जुड़ेंगे तो
ठीक
हम
है।
ऑन करते हैं।
थैंक यू सर, थैंक यू।
ओके।
वाह। नमस्कार।
हेलो, क्या मुझे सुन पा रहे हैं सभी?
Yes, sir.
गुड मॉर्निंग एवरीवन।
Good morning, sir.
आज का हमारा टॉपिक है ए सिविल इंजीनियरिंग जर्नी बाय इंजीनियर अमित कुमार दास। Distinguished EPCM executive and former chief general manager at Engineers India Limited, with over 38 years of comprehensive expertise leading high value mega projects, greenfield, brownfield, and revamp across refineries, petrochemicals, offshore, non-ferrous metallurgy, nuclear power, cross-country pipelines, and infrastructure sectors in India and overseas, recognized for an exception capability to simultaneously manage the risk and deliver multiple mega projects executed across geographically dispersed locations under diverse execution models: LSTK, PMC, LEPCM, and EPC, adept at bridging corporate strategy with multi-site execution, ensuring institutional adherence to HSSEMS quality management and aggressive cost schedule milestones ex- experienced in ex- executive level client management, statutory compliance, and steering cross-functional international consortiums, multidisciplinary engineering, and construction teams towards profitable project closures. Now I request Engineer Das, please take over.
Thanks a lot, Mr. Singh, for such a nice introduction. Namaskar and a very good morning to all of you. My dear registered engineers of Engineering Council of India, it's a privilege to be here today as part of the Engineering Council of India's continuing professional development, that is CPD program, which is undoubtedly a great initiative. I sincerely thank the Council for providing me with this opportunity to interact with the fellow engineering professionals and share practical knowledge gathered from industry experience. Engineering education provides us with theoretical knowledge, while industry transforms that knowledge into practical solutions. Today's session is designed to bridge that gap. Why are these sorts of sessions are so important? Many engineering graduates possess strong theoretical knowledge, but have limited exposure to practical site conditions. On the other hand, industry expectations today extend beyond textbooks. Institutions develop technical foundations, while industry develops professional competence. When both work together, one becomes confident professional, and then they are very much incompetent and ready to contribute fully, properly, and most effectively. As most of you are practicing engineers and quite experienced professionals, I encourage everyone to be fully involved during this session, because we believe that engineering grows through curiosity and continuous learning. One sincere request: please don't consider this session as a lecture, but like sharing of experiences. We might have studied a lot during our student days, but with the passage of time and work pressure of the typical construction site life, we tend to forget some of them. We'll try to revisit our institute days and get refreshed a bit today. It is imperative that we adopt the motto of stay ahead, stay relevant, and stay connected. Through stay ahead, we should review systems and practices often and adopt knowledge of global best practices and research that can apply to business. Additionally, we can also incorporate various forward-looking initiatives. And with Stay Relevant, we try to attain programs specific to businesses, to go beyond traditional project management practices and delve into the latest contents that help the business. And by way of stay connected, we must engage with businesses to understand the growing needs of the business and thereby add value to the projects being executed. I have titled the topic for today as a civil engineering journey. Since the topics to be covered as a part of this program will have sequel, that is continuation. And moreover, learning is nothing but a journey only. My objective is not only to explain the primary and main civil engineering concepts, but also to demonstrate how these principles are applied on real construction projects. Before we begin, let us understand what we aim to achieve today. During this session, we'll travel through the complete life cycle of a civil engineering project. We shall touch upon the importance of soil investigation, foundations, piling, concrete technology, reinforcement detailing, formwork systems, construction equipment, quality assurance, etc., etc., etc. By the end of this session, we should be able to connect classroom concepts with actual site practices and understand how engineers effectively make technical decisions every day. Again, one pertinent question may be, why civil engineering? The answers, as per me. The first reason, I understand that the majority of today's target audience is primarily civil engineers. So it will be a sort of refresher course for them. Another strong reason, for the rest of the participants who are from the other engineering disciplines, this sort of elementary knowledge, concept, and ideas of practices being adopted in the industry is quite essential as we gradually move from discipline-specific engineers to multitaskers in today's world as per the growing industry requirements. And finally, maybe most justifiably, civil engineering is the mother of engineering. A project starts with civil engineering, isn't it? What is civil engineering? Civil engineering is much more than construction of buildings. It is the profession that develops the infrastructure supporting modern civilization. Every project follows four major stages. The first stage is design, where engineers identify the need, conduct surveys, perform required analysis, prepare drawings, etc., etc. Different types of loads are there: dead load, wind load, seismic load, live load, etc., etc., etc. Then second stage is the construction. The ideas become reality through planning, resource management, quality control, ensuring safety, etc. Next, coming to third stage is maintenance, which ensures that structures continue performing safely throughout their service life. And finally comes demolition or rehabilitation, when structures become unsafe, obsolete, or require redevelopment. One very important aspect to be noted: demolition is also equally important and critical like construction. In fact, at times, demolition is more critical than original construction itself, from the points of view of maintaining stability and soundness of the existing structure and ensuring safety of the all concerned and environment as well. Every civil engineer contributes to one or more of these stages during their career. Civil engineering has a remarkable history dating back thousands of years. Ancient civilizations such as Egypt, Mesopotamia, and Indus Valley demonstrated extraordinary engineering capabilities. One of the earliest known civil engineers was Imhotep, who designed the step pyramid of Saqqara in Egypt. Later, the term civil engineering was introduced to distinguish the civilian construction from military engineering. So you can see another reason and instance of why the civil engineering is regarded, I say regarded, as the mother of engineering. John Smeaton, who designed the famous Eddystone Lighthouse, is widely regarded as the first modern civil engineer. These pioneers laid the foundation for today's engineering profession, where technology continues to transform how we design and construct infrastructure. Let us appreciate some outstanding engineering achievements. We all heard of the world famous the Burj Khalifa at Dubai, which is the world's tallest structure and building of 830-meter height. It demonstrates the possibilities of high-rise structural building and structural engineering. The Danian Kunming Grand Beach of China, the world's longest beach spanning 164.8 kilometers, it showcases the large-scale bridge engineering and transportation infrastructure. China's Jinping One Dam, that is the world's tallest dam of 300-meter height. The Gotthard Base Canal of Switzerland is the world's longest railway and deepest traffic tunnel, having the length of 57 kilometers. It represents the excellence in underground construction and tunnel engineering. Now let's focus on some of our
Amit sir,
Sir,
sir slide show कराई है
सर आपकी स्लाइड नेक्स्ट नहीं हो रही है, आपका फर्स्ट स्लाइड ही शो हो रही है.
oh, sorry.
जस्ट प्रेस डाउन की.
मैं तो डाउन कर रहा हूं सर. कौन सा स्लाइड में है?
जूम पर आना होगा आपको.
कैसे आए? बोलिए तो.
जूम पे आ गए हैं आप, जहां स्लाइड शो कर रही है.
अभी भी नहीं दिख रहा है.
नीचे एक आइकन होगा सर, बार की पे नीचे.
अभी कौन से स्लाइड में है अभी हम?
आई थिंक 8 और 9.
एट तो दिखा है ना, बुर्ज खलीफा?
नहीं दिख रहा है सर, फर्स्ट ही दिख रहा है अभी.
ओहो.
जूम में जाके करना है सर. जूम पे जहां स्लाइड फर्स्ट स्लाइड शो हो रही है जूम में. आपने मिनिमाइज कर दिया है जूम को आई थिंक.
अभी देखिए तो.
हाँ अभी नेक्स्ट हुआ, अभी हुआ.
अभी हुआ ना
जी.
ठीक है ना सर? अभी बुर्ज खलीफा दिख रहा है?
बुर्ज खलीफा दिख रहा है.
थैंक यू. सॉरी एक्सट्रीमली सॉरी. ठीक है ना? अभी तो मतलब खास कुछ सिविल इंजीनियरिंग कवर नहीं किया.
टनल इमेज दिख रही है.
हाँ ठीक है. सॉरी, एक्सट्रीमली सॉरी. अभी हम यहाँ पे थे ना, दैट इंडियन. I have covered that Gotthard Base Tunnel of Switzerland. ये हो गया अभी.
Yes.
Now let's focus on some of our own Indian engineering marvels. The reconstruction work of the famous Pamban Bridge in Tamil Nadu was having the target schedule of 6 months by Indian Railways, which was eventually completed in just 46 days. I repeat, only 46 days, under the very able stewardship and leadership of the eminent engineer E. Sridharan sir. Then we have the signature bridge at Delhi. It's the India's first asymmetrical cable stayed bridge. Next slide हुआ sir?
Yes sir.
Yes. ठीक है. I would like to highlight that each of these projects are somewhat unique in nature, be it in size or design concept or nature of criticality, etc. All of them required collaboration among structural engineers, geotechnical engineers, transportation engineers, environmental specialists, construction professionals, all. These marvels remind us that engineering is not simply about calculations, it is about solving society's most challenging problems and aspirations as well. See, every structure ultimately transfers its load to the ground. Therefore, understanding the behavior of soil is one of the most important responsibilities of civil engineer. Before construction begins, engineers conduct geotechnical investigations to determine soil properties, groundwater conditions, and bearing capacity. Without proper soil investigation, even the strongest structure can experience excessive settlement or failure. Remember the simple principle: a strong building always begins with a strong foundation. Now, we'll touch upon various soil improvement techniques. Natural soil may not possess sufficient strength. In such situations, engineers improve soil properties using various stabilization methods or techniques. These include cement stabilization, thermal stabilization, electroosmosis, grouting, geotextile, reinforced earth, etc. You see cement stabilization, grouting we can show, geotextile and fabrics or geogrids, reinforced earth. Choice depends upon soil type, project requirements, groundwater conditions, and of course, economic considerations. Modern ground improvement techniques enable engineers to safely construct highways, airports, bridges, ports, industrial plants, and high-rise buildings, even on weak soils, by way of soil stabilization or soil improvement. This concludes the first section of today's presentation. In the next part, we shall move into foundation engineering, piling system, and various other construction practices. Now that we understand the importance of soil, let us move to the foundation, which is the most critical component of any structure. A foundation transfers safely the load of a building or to the structure to the ground without causing excessive settlement or failure. Some sort of failure or some sort of settlement we allow in our design. The selection of a foundation depends on the soil bearing capacity, groundwater level, structural load, and site conditions. These are all the types of foundations. The foundations are broadly classified into shallow foundations and deep foundations. So some of the shallow foundations are economical and are used where the soil has adequate strength near the surface. And deep foundations such as piles, just a minute. Deep foundations such as piles and wells are adopted when the upper soil layers are weak and the loads need to be transferred to deeper or stronger data. See some of the deep foundations we can show here. Now, as we know that a good engineer never selects a foundation based on cost alone. It is based on safety, durability, and long-term performance must always come first. Pile foundations are among the most widely used deep foundations in modern construction. This is one sand compaction pile. These are piles for ground improvement. You can see another vibroconcrete columns. Transfer structural loads through weak soil into stronger layers below. They are extensively used for bridges, high-rise buildings, ports, then your flyovers, industrial plants, and offshore structures. All. Depending on project requirements, piles may be precast, piles may be casting situ, casting may be steel, timber, or composite. They may be also classified as displacement piles or replacement piles according to the installation method. See, these are all concrete pile, this is a steel tube, timber pile, then screw pile, passport water jet piling, open hole auger boring, then continuous flight auger piling, overburden drilling, eccentric piling. Some of the terminologies: pile cutoff level, then pile termination level, then board pile replacement pile, then driven pile, that is a displacement pile. During construction, engineers monitor pile depth, then verticality, then concrete quality, reinforcement placement, and termination level. Proper quality control during piling is essential because defects below ground level are difficult to repair after construction. So we should be very, very much careful while executing piling. Now, let us move towards concrete technology. Concrete is often described as the backbone of modern structures. Concrete, what is concrete? It is an artificial stone produced by combining cement, coarse aggregates, fine aggregates, and water in carefully controlled proportions. We can think of just laddu, where all constituents are there, and the gur or the syrup is the binding force to have that beautiful laddu. So in that concrete, we can have coarse aggregates, we can have fine aggregates. See, Concrete performs exceptionally well in compression. Please remember it, not in tension, but has very little tensile strain. That is why reinforcement steel is also embedded within concrete to create reinforced cement concrete. This is about the cement. There are so many types of cements are there. What is the use of cement? Then, of course, the water should be potable and pH value of less than 6. The performance of concrete depends upon the quality of its ingredients, water-cement ratio, batching accuracy, mixing, placing, compaction, and finally curing. This is the grade of concrete we usually denote, that is, suppose M25. M stands for mix, and 25 is the characteristic compressive strength in Newton per mm square. If we test 150 mm cubes at 28 days, that strength should be not less than 25 Newton per mm square. Remember, high quality concrete is not achieved simply by adding more cement. There is a misconception that you put more cement and you will get better strength. It's not. It is achieved by maintaining proper proportions and good construction practices also. And sometimes we use admixtures also as per the specific requirements. Some of the strength of concrete, see, high strength concrete is 65 to 100. Ordinary concrete is M10 to 20. Below that, it is not actually this, the VCC. Standard concrete is 25 to 60, and high strength concrete is 65 to 100. There are two types of mixes, concrete mix. One is nominal mix, another design mix. The differences are there. So 20 and below are the nominal mix, and design mix is all grades you can do as per your proportions and based on the reservoir code. So standard mix is concrete mix is defined by the ratio of volume of cement, Fa and V, but design mix always by weight. That we must remember. After knowing what is concrete, now let us know about concrete production and placement. See, you can see this is the tilting drum mixture for small set of this. The non-tilting drum mixture is there. Modern is reversing drum mixture, the mini batching plan. Modern construction uses advanced equipment to produce and transport concrete effectively. That is called batching plants. This is ensuring accurate proportioning of materials. And this is some of transit mixtures. These are to transport concrete while maintaining workability also. The transit mixture, and this is concrete pump. Concrete pumps and these boom placers, they deliver concrete safely, locations at great heights and long distances that are otherwise difficult to reach. And during placements, engineers must avoid segregation, excessive free fall, and delays that may affect workability. Also, proper planning and coordination between batching, transportation, and placement are essential for achieving durable and high quality concrete structures. We have just told that concrete is very much strong in compression, but not in tension. So now coming to reinforcement. Concrete alone cannot resist tensile forces effectively. Reinforcement still provides the tensile strength required for beams, slabs, columns, and foundations. You may remember reinforcement just like that as a skeleton of a human body. Just as bones provide strength and stability to our body, reinforcement provides strength and ductility to concrete structures. Different grades of TMT bars are selected depending on structural requirements. See some planes reinforcement to TMT bars FE, then FE plus, then FE, all this formulation there. Why do we have lugs and reefs? To hold the people I love very much closer. See, this is the grade of reinforcement. How do you denote? Fe, for instance, 550D. Fe means ion, that is a ferrum, is a scientific sign. Then 550 is the yield stress in Newton per mm square. That is the strength of that reinforcement. I mean that iron. Area of steel reduces if higher strength steel is used. And this D is the category for enhancer. There's a different types of there. Now we are coming to some typical reinforcement details. See, usually there is a lap is there. Then here is a development length. There is a construction joints. These are all there in the codes. And as per that, we go ahead. Proper anchorage, development length, lap length. Then spacing and concrete cover ensure that reinforcement performs effectively throughout the life of the structure. These are the concrete joints. Concrete mainly carries shear forces, where shear force is 0 or close to 0. And reinforcement lapping, reinforcement mainly carries flexural and tensile strengths, where bending moment is 0 or close to 0. So there is a lot of misconception at site, different places, where to put that lapping in the upper layer or the lower layer reinforcement. So that should be very clear from this diagram. And where to put the construction joints while putting a long time of pour. These are all the typical reinforcement details of a beam. Top reinforcement, bottom resistance stirrups are shown. Another one, this is a floor beam. Cross section and longitudinal view, both are there. Typical reinforcement details for slab, both ways. Reinforcements are there. This is a typical bar bending schedule. These bar bending schedules are prepared prior to the start of the job, and accordingly reinforcements are cut and placed in the job to avoid any wastages. Now we are coming to formwork systems. Formwork is the temporary mold into which fresh concrete is placed until it gains sufficient strength. So formwork will be removed only after it gains concrete which was poured inside it gains sufficient strength. An efficient formwork should be strong, accurate, so that there should not be rework after that, and reusable, economical, and safe. This is the type of formwork you can see. The common terminal is soffit, then centering, then side, runner, prop, mold oil, or release agent. This is a classical conditioner member. Now I don't think this is used anywhere. Today, for faster construction or improved quality, engineers use several modern systems such as the plastic formwork, the cup block system, the Doka formwork. Then we have bracing formwork, the slip form, climbing form. Poor formwork can lead to dimensional inaccuracies, leakage of cement slurry, surface defects, or even collapse during concrete. Therefore, formwork inspection before pouring concrete is a critical quality control activity. Once concrete is placed, proper compaction removes entrapped air and ensures complete filling around reinforcements. This is the needle vibrator, we can say, for use for compaction of concrete. The surface vibrator or form vibrators. They are commonly used depending on the structural element. Vibrating tables. After completion, curing becomes one of the most important construction activities. Curing maintains moisture within the concrete, allowing cement hydration to continue and strength to develop. Inadequate curing can result in reduced strength, cracking, poor durability, and increased permeability. See, a lot of types of curing are there. By ponding, this is use of curing compound, membrane curing, and steam curing. Successful structures are built not only by good design, but also by disciplined construction practices. This completes the second part of our discussion. We shall now move to concrete defects, major concrete quality control, and some more construction equipments being used extensively. My dear fellow engineering professionals, no construction project is completely free from challenges. However, good engineers identify problems early and implement corrective measures before they become failure. Some failures are there. See, this is a formwork failure. It is a disaster. This is another reinforcement failure. Some common defects observed in concrete include segregation. This is the segregation of concrete. Then bleeding, delamination, honeycombing, cracking and crazing, blistering, and efflorescence. See, segregation occurs when coarse aggregates separate from cement mortar due to improper handling or excessive free fall. Then bleeding results from excess water rising to the concrete in the concrete surface. After vibration, that water comes out. Honeycombing usually occurs because of poor compaction or insufficient concrete around reinforcement. And cracks may develop because of shrinkage, thermal effects, overloading, or poor curing. As engineers, our responsibility is not only to repair defects, but also to prevent them through proper planning, supervision, and quality control. Always remember the saying, quality is never accidental. It is the result of intelligent effort and disciplined execution. So what we say, quality control is the backbone of every successful project. Every stage of construction, from soil investigation to the final finishing, requires inspection and testing. Concrete cube testing is one of the most common methods for evaluating compression strength. Although cubes may be tested at 7 days to monitor progress, but the standard acceptance test is performed after 28 days of curing. Actually, there will be 3 sets of cubes should be taken, and it will be tested in the typical crushing machine and to have the strain. This is the sampling of the cubes to be taken depending on the cubic meter of the concrete being poured. This is the character strength of the concrete. It is defined at the strength of concrete below which not more than 5% of cube results are expected to fall. Concrete, we know that it is neither homogeneous nor isotropic material like steel. Then compressive strength of different cubes from same concrete mix may vary minutely despite all site controls. And the permissible limit of standard deviation is compressivity is included in IS 456. That is the relevant code for concrete. This is the thing, not more than 5% samples fall below the characteristic strength. And this is the formula is there, that FCK is the character strength for that, and S is the standard deviation. Cubes are made in controlled environment and cured in submerged condition. Besides cube testing, engineers inspect reinforcement placement, concrete cover, formwork alignment, pile integrity, material quality, workmanship, everything. Parallelly, documentation is also equally important. Site records, inspection reports, and test certificates ensure traceability and compliance with engineering standards. Remember that quality cannot be inspected into a project after completion. So it must be built into every activity from the very beginning. Now, modern infrastructure projects rely heavily on mechanization. Excavators perform earthwork efficiently. Backhoe loaders, these are all versatile machines for excavation and material handling. Dumpers, these transport expedited materials. Transit mixer and concrete pumps, already we have covered earlier. Mechanization increases productivity, improves safety, reduces labor dependency, and shortens project duration. However, equipment alone cannot or does not guarantee success. Skilled operators, preventive maintenance, proper planning, these are all equally important. Now we will show that example of one specialized type of construction activity. This is a vacuum dewater flooring, concrete with low water cement ratio but high workability. How to do it? This is a high strength and durability due to low water cement ratio. Another one, compacted with power floater to improve the compaction and smoothness of the floor. This is usually used in industrial flooring. Today's construction industry is evolving rapidly. Successful engineers combine technical knowledge with leadership, communication, and ethical responsibility. Some important best practices include following approved drawings and specifications only, no compromise on safety at all at any stages, plan your work prior to the execution, use of quality materials and approved construction methods, carrying out regular inspections, encouraging teamwork among engineers, contractors, and consultants who all are involved. This is also, I should say, it's a partners in progress. All are partners. And then minimizing environmental impact through sustainable construction practices. Engineering is ultimately about protecting human life and creating infrastructure that serves society for decades. So every decision we make on site has long-term consequences. Future of civil engineering is really exciting. Nowadays, we are having the digital technologies which are transforming how projects are designed, executed, and maintained. Artificial intelligence is improving project scheduling, quality prediction, and maintenance planning. Automation, robotics, prefabrication, then 3D concrete printing, and smart materials are redefining modern construction. Building information modeling, that commonly known as BIM, that enables engineers to integrate design, the Tekla and all these already softwares are there, modules, planning and execution with a single digital platform. Then drones are now used for surveying, inspection and construction monitoring. At the same time, sustainability has become a major priority. Future engineers must focus on reducing carbon emissions, conserving natural resources, and constructing environmentally responsible infrastructure. The engineer of tomorrow must combine technical excellence with innovation and sustainability. So the key takeaways of today's discussion, before concluding, let us quickly summarize today's discussion. We explored the complete journey of civil engineering from design to demolition. We understood the importance of soil investigation and foundation selection. We discussed pile foundations, concrete technology, reinforcement, formwork, and construction equipment. We emphasized quality control, proper curing, and defect prevention. Finally, we looked toward the future of civil engineering through digital technologies and sustainable development. I hope today's discussion and this session has helped you to connect classroom knowledge with practical engineering applications. Being the Sunday, I must thank that after working for 6 days, extended hours at site, still you could have some time and be attentive to attend the session. One thing you must remember, never stop learning, because engineering is a profession that continuously evolves. My dear fellow engineers, thank you very much for your patient participation and attention throughout this session. I sincerely appreciate the opportunity provided by the Engineering Council of India to share my experiences with all of you. I hope today's discussion has inspired you to view civil engineering not merely as a profession, but as a responsibility towards the society. Every bridge we design, every building we construct, and every road we develop directly improves people's lives. As a concluding message, I urge all of you to always remember, engineering is not simply about constructing structures. It is about building a safer, stronger, and more sustainable future. I wish each one of you great success in your professional career, in particular, and journey of life as a whole. I'd also like to convey that I shall be glad to be a part of such initiatives in future from ECI 2. Namaskar and have a good day.
Thank you, sir. Thank you very much.
Thank you, sir. Thank you very much for your very knowledgeable session.
Thank you, sir. Thank you so much.
Thank you very much.
Thank you.
If anyone have a question, please ask.
So I do have a question. I mean, I looked up at your profile. It's based on you have experience across.
Please allow me a
oil-
minute. I'll just change my layout actually.
You,
Because I
you
would
do
like
have
to-
experience in oil and gas industry. Could you please share some experience or like what's the kind of impact and the kind of projects you've worked on in that particular industry? Since I have
sure,
done
sure.
bachelor's in chemical engineering.
Oh,
and-
you are in chemical engineering, but you are working at site or?
No, I'm not working at site. As of now, I mean, I did my master's in US, but had to come back in India, and I'm trying to figure out like what's the right space to navigate things ahead. I mean, US companies work on a different grade scales, and I'm trying to figure out like in India's context, basically Southeast Asia, how do things work around here? I mean, that's what I'm trying to figure out.
Oh, nice. After this Middle East war, I think it has become more pertinent. See, now government is gearing up not only the refineries at petrochemicals, but also developing that strategic storage. You must have heard that strategic storage. See, during this war also, we didn't bother so much, and at every petrol or diesel filling station, you must have seen that nobody has had any problem that you are not getting that petrol or diesel at the time. Though there was so much problems of Hormuz Strait, that ships are not allowed and all these things. And also though initially there was some hiccups in LPG cylinders delivery in our domestic purposes. See, prices, etc., that is different issue. That is government's prerogative, and that is the demand supply equation and all these things. I should not comment on that. But availability part was maintained. See, already we have that strategic storage at Padur and Mangalore and also Visakhapatnam. And in near future, there will be a development in Odisha also. That is a very bigger one. So at any point of time, almost 74 days of petroleum crude, is available in our country. So we can sustain that thing. So that was developed. So that is a great initiative done. And fortunately, my ex company, that is Engineers India Limited, they were involved in construction of those strategic reservoirs also. Apart from that, in private sector, the Reliance is there, then your Adani is also now it is there. And in public sector, you can have ONGC, IOCL, HPCL, BPCL, Numalika Refinery Limited, Oil India. So tremendous scopes are there. And of course, in consultancy organization like Engineers India Limited are there. So I don't think there will be any dearth of opportunities in India so far as your chemical engineering part is concerned, and specifically petroleum industry, from which I came from. Does it satisfy some of your queries?
Yes, sir. Thank you so much.
Most welcome. What is your experience, by the way? How many years?
I'm barely into my early career profession. I mean, I've done masters in material science and engineering as well in US. It's mainly towards semiconductor, developing next generation devices. But unfortunately, the India's ecosystem is being developed as of now based on
So far
the
as
current geopolitical dynamics.
yeah.
So
As you mentioned that semiconductor, see, is a very big plant coming up in Gujarat and also in Jagir Road in Assam. Okay, near Guwahati.
yes.
That
And
is
they're
quite,
working on the what we call basically OSAT, basically packaging and all those kind of things. I work more on the development of next generation of devices, basically in research labs as well during my master's degree as a part of curriculum. But unfortunately, due to the visa situations and everything, I had to come back. Now I'm trying to figure out like how do I join back the industry, figure out like what's the way to
due to
navigate
the
ahead, and then
due to the
fortunately,
maniacs.
Yograj ji, I met Yograj ji and I talked about them like this is the situation, and somehow I was able to navigate things around. He's like, come and join the Engineers Council of India. Maybe you'll be
Nice.
able to figure out, learn from
Very
people who
nice.
have been in the industry for many, many years.
And you can connect me also, no problem, if you feel so.
Sure.
And see, in 27,000 crore project is coming up from CIDC as a team only. I went to that project in Jagir Road in Assam to evaluate their project. It has only have 8 to 9 months already. And that is also a big project being constructed by Tata Semiconductor company. And there also you can have TCE, they are the consultant, okay? And Tata Projects is the executing agency, and L&T is also there. So you can think of that also.
I see.
From semiconductor point of view. Okay, and it is a very nascent stage. Okay, construction is just going on.
Okay. Thank you so much, sir. Could you share your details? I'll reach out to you. I mean,
Yes, sure. You can have from Mr. Yograj also, I think.
Okay.
No problem. Okay,
Thank you,
my
sir.
phone number and email ID both are there.
Sure, sir. Thank you. Have a good one.
Most welcome.
Yeah, good afternoon, sir. I'm Gautam Srivastava. Can you hear me?
Your voice is very low, sir.
I'm Gautam Srivastava. Can you hear me now?
Sir, maybe a bit louder, if you don't mind.
You speak a little loudly.
Hello. Am I audible now?
Yes,
Yes.
you are, sir.
So in one of the slides, I saw this vacuum dewatering system map.
put on the floor of the concrete. So we have encountered some problems while doing so. I don't think there is a mechanism, a perfect mechanism in place which allows the mat to, I mean, for how long the pump is to be run, because the purpose of the mat is to extract the excess water and
Yeah.
maintain the water cement ratio so that the upper layer of the concrete doesn't get eroded
Yes.
because of the excess water. But what happens in practical usage, uh, manual doesn't strictly, confirms the duration for which the pump is to be run, and due to that variation, what happens? Even the excess water gets extracted, which results in failure of the RCC floor. And we have encountered such problems in quite a few warehousing projects where we have executed flooring using vacuum dewatering system. So how to control it?
Hello.
Yeah. Hi. Yes, sir.
Tell me, what is your actually, what do you mean to say? No, you have done in which projects? Can you mean? You are from which organization, by the way?
So I was with Kunj Lloyd earlier. I was also in oil and gas industry.
Very good.
Executed few refinery projects in Haldia and Barauni, Paradeep.
Okay. I was also associated in Haldia and Barauni, not in Paradeep.
Yeah. And then I was involved in MSQ project in Barauni, hydrocracker and hydrogen projects. Lurgi was at that point of time PNC of, and recently when we did one project in Aishwarya project in Haldia, the last project.
Aishwarya. Okay. There EIL was also there, I think.
Yeah, yes.
Mr. Jayanta Bhattacharya was there, I think.
Yes.
And Shishir Mishra also there.
Yeah. So, and here now I left Kunj Lloyd in 2018.
Okay.
Early 19. And after that, I'm doing my own consultancy work here in Bihar.
Fantastic.
And doing some industrial projects in ITC, cigarette manufacturing company here in Bihar. Here we did quite a few projects of, the warehouses were demolished, the floor were demolished completely, and fresh flooring was done using vacuum dewatering system. In few of the godowns, we found that the pump was run for a little longer, and that resulted in
excessive bleeding.
Yeah. And then cracks developed. But we couldn't get an exact solution to it because nobody could, confirm what is the exact duration for which the pump is to be run so that it doesn't extract the excess water from the concrete and disturb the water cement ratio.
You are 100% correct. By the way, it was done departmentally or through some specialized agency?
It was done through specialized agency also. There was an agency from Calcutta which carried it out.
Okay. Because whatever I have supervised, some of that problem I have not faced. And see, this is basically done by specialized agency. So when the finer know-how, they don't share actually. We do only observe, but that they don't share practically. But this problem I have not faced. Maybe it's a good thing that you have told. I'll also explore this thing with some of my colleagues who are still in the job. And I'll your details will be available with Mr. Yuvraj Singh, I believe.
Yes.
Yes. Then we'll interact. Okay.
Thank you, sir.
Okay. Nice for pointing out. It's really maybe it's some late eye opener for me at this stage also. Thank you.
Okay.
It was a wonderful lecture, and I thank the professor of practice who has delivered it so well. And
Thank
I hope that this series continues. But I just wanted to kind of attract the attention of all our participants here. Majority of our projects are actually looking into time and cost over time. And that is a very, very sad situation. In fact, the recent example, if I can give, is that much awaited bullet train project itself is about 7 to 8 years or maybe 9 years delayed. Secondly, there is another problem, and that is that our engineering staff is basically almost non-existent. They don't have much field experience, and although they may be holding the degrees and diplomas and MBAs or whatever you have, but fact of the matter is that they have little on-site experience. Now, I was listening to you. You could connect that what exactly was happening in other petrochemical complexes, and then the kind of old historical things were brought in, the problems, the difficulties that were basically enumerated. But what I feel personally, that unless otherwise the knowledge is disseminated, and especially the people who have the experience, they share it with those who are in the process of learning things, and to tell them that they should not commit the kind of mistakes and problems which they faced in their career in past. And this is very true for all the practicing engineers. In fact, I also have faced several, you know, I would call them calamities because of not being very conscious about the kind of things. All of us have committed mistakes and blunders. And the best thing is to learn from somebody else's mistakes and blunders. That is the first thing that I will say. So let us basically speak within our own group, encourage more and more engineers to come and join these deliberations, which is extremely important, and it is going to be eventually very beneficial to them. One issue which is very, very significant is that when we started working on the industrial and infrastructure projects way back 50 years ago, and I have been associated with it, we had people who were coming from all parts of the country. I'm talking about the workers, the foremen, the supervisors, and in fact, foremen and supervisors were the experienced workers who were basically taking over the responsibility. They would not be having any kind of degrees and diplomas and certificates, but they were very, very experienced and they guided the main workforces. So these are the areas where we are now totally lacking. What is the net result? The net result is that our projects are getting delayed. The money or the kind of budgets that we have, and the two bulk of it comes from public exchequer. Uh, this is something that is being frittered away. This is the malady that we have. So, to solve it, there are solutions that we have implemented now. And let me also tell you that we have gone to a level where we are even picking up the normal construction workers. And when I say construction, I am not only meaning masons, carpenters, barbenders, and people like that, or welders. I am talking about the construction workers who are even working in the
Sir, your voice is not coming. Please unmute yourself.
Oh, I'm sorry. Uh, what I was saying that I got disconnected for a while and now I'm back. This is a very interesting program which is now aiming at the construction workers to be converted into field engineers. Bachelor of Vocation is a degree which is recognized by University Grant Commission, and 6 universities are there with whom we are basically launching this project. Happy to tell you that more than couple of thousand students are today working, and many of these workers are those who had the aspiration to become engineers, but unfortunately, because they come from the families which cannot afford their university education, which has become too expensive, now is the opportunity for us to convert them. Why are we doing it? We are doing it first to meet our own requirements. Second, there is a huge international work that has come up now. You all know about the Middle East, Gaza, Palestine, and other places, and they need to be reconstructed. And who's going to reconstruct it? It is basically our people who are now today the youngest demography in the world. They are going to do it, but believe you me, we have to prepare them. And who is going to prepare? It is only experienced people like you who are going to do it. So wherever you are working or wherever you are giving your advices, please talk to them. I will ask Mr. Yograj to share the details with you. Please go through that and let us work as one unit to make sure that the infrastructure development in our nation is comparable to the best in the world for that matter. Thank you very much, and
Thank you, sir.
especially to the speaker. Thank you very much.
Thank you, sir. Thank you.
Thank you.
Thank you.
Anyone have a question? Please ask. क्या किसी का कोई सवाल है? दास साहब आंसर देंगे? Okay, no one. Thank you, Das sir,
Thank you
for
very much,
a
sir.
very important and sorry. Thank you, Das sir, for a
Thank you,
very
sir. Thank you.
knowledgeable session.
Thank you,
And
sir.
thank you everyone for being here and stay with us. Thank you, everyone.
Thank you. Thank you.